Well, hello, and welcome back. I'm AJ O'Neill. I've got the camera angle wrong. This is Beyond Code Live, and we're going to talk a little bit about Array.reduce and how to do a sequence of promises. So let me pull up the chat here. Let's see. So, hello to those of you joining in. Feel free to ask questions, and I'm also going to bring in our little expert question asker. So give me just 1 second. Join now. Oops, there we go. I cannot type. I'm typing the wrong thing over and over and over again. Okay. Expert question. Yes, that is you. All right. So give me just 1 second here, folks. Sorry for the wait.
Yes, that is you.
All right.
That was a good save.
All right.
Yeah. Turn off that extra audio there. Otherwise,
How am I coming in?
the echo. I got the echo of myself.
That was a good save.
You got to stop that.
Turn off that extra.
There we go.
Yeah. Okay. Cool. All right. So,
but I can't hear you. I'm gonna put on some headphones.
let's see. Oh, it helps if I unmute my mic. It helps if I unmute my mic. Okay. All right. So I'll do a little explainer on this, and then you can just interrupt at any time, ask questions. Those of you that are on the chat, hello. Feel free to interrupt and ask questions anytime. So first of all, I have to say I am so disappointed with what MDN has become, because this used to be a great resource for developers to be able to come and learn about JavaScript. And what it's become is basically a place for people with really complex ways of thinking to show the most complex ways of doing things. So I'm going to bring up an example. Let me just click over here 1 second, and we'll go through this. So reduce is more often abused than used properly. So I'm going to show you. This is really the only acceptable use case. Let me do total equals. There we go. This is really what reduce was intended for. So there's this pattern called MapReduce. There's a couple of talks by Google that you can watch. There's basically a lecture series for it. And MapReduce is a pattern for distributed computing and functional computing. Hey, what's up, Kirglo? Where you go through some large set of information, say all of the pages on the entire internet, and you perform an operation on them, map, and maybe give them a score. So for every page you encounter, you map over the pages, you give them a score, and then you reduce. You aggregate the metrics by which you've given them scores to produce a final result, such as PageRank. So this is kind of Google's secret sauce. And so I think at least for me, when I hear the term MapReduce, I think PageRank, because that's where it seemed to get the most buzz back 10 years ago. You don't have this sort of problem in JavaScript, even if you're using Node. But because reduce is one of these functional methods, people like to talk about using it. Because functional programming has become almost a religion. No, it's just a religion. It is not almost. It is a religion. And so people try to use functional paradigms even when it doesn't make sense. So, okay, let me cut to the chase here. Reduce is intended to aggregate something. Typically, it's numbers or some sort of scoring system. So you want to be able to take an array, say the numbers are 1, 5, 7, 42, 8, 3, and you want to add them all together. And I actually did this wrong. I have a bug in this, but this is okay. This will actually demonstrate. I'll say subtle difference, and this is really important between these two. So when you reduce, you have an accumulator or an aggregator, and that is the total that you're building up. If you should supply an initial value, such as 0 if you're dealing with numbers. And that initial value in the very first run of the reduce is what is the first accumulator. If you don't supply an initial value, you would think, well, then this would just be undefined or null or something like that. And you don't want that. So you want to supply an initial value that's kind of a good zero state. And then what's going to happen is that accumulator, the initial value 0, you're going to add with whatever your element is, which let's say it's 3 or 5 or whatever. And then you're going to return that to become the next accumulator. So this is called folding or reducing. So you're taking something and you're aggregating it together. And then at the very end, what's going to get returned is the total of all the things that have been reduced. Now, there is, I would classify this as a bug. Other people see it as a feature, but I see it as a bug. If you forget to add the initial value, what it will do, which happens to work in the case of numbers, but will cause bugs in many other cases, is that it will use the first element of the array as the accumulator. So let me bring up a terminal. Let's actually just bring up here in the browser, and let's just try this out. So we're going to have 1, 5, 10, 15. I'm putting these in numerical order. Let's not do that. And then we're going to do .reduce. And then reduce right, the difference is just that it goes in reverse. So reduce goes from first to last, reduce right goes from last to first, which there are cases where you want to do that, but I would recommend instead, for the sake of simplicity and ease of reading, that you just do .reverse. But since that auto-completed and showed up there, so we got our accumulator, and then I'm going to call this n. So I think I actually might call this total, because that is more correct to this particular bit that we're doing here. And let's throw a -3 in there just for fun. Okay, so if we put in here 0 as our first value, and let's, whoa, oh no, dang it. There we go. Let's go ahead and console.log here too, just so that we can see what the value of n and I are. Let's go ahead and put I here. So we'll put it there. All right, so we're going to see 0, 1, 2, 3, 4. We're going to see those in order there. All right. I'd be interested to see if reduce right shows the things go in the opposite order. So we're going to return total plus n. And so let's look at n and let's look at total. So we'll see how this goes. Whoops. Unexpected identifier. What did I do? Oh, I didn't put a dot there.
Array, yeah.
Thank you for that. All right. And hello to everybody joining in. Feel free to ask questions, make comments, heckle, whatever you want to do. The more engagement, the merrier. Thumbs up if you got them and you feel this is useful. So 0, 1, 2, 3, 4, 5. And then we see 0, 1, 2, 3, 4, 5. So that matches, right? And then we see our numbers coming through. So first 1 comes through, then 5, then 10, 15. You know, this is intuitive. It makes sense. And then this is our running total. So our total starts at 0, and then our total goes all the way up to 28. So every time our total is getting a little bit better. Oh, actually, our final total is 35 here. So that's the very final thing that we get is because the last operation, the total starts at 28, and then we add 7 to it, and we get 35. So this is clear, yeah? Okay, we got a thumbs up on that. Great. So now I'm going to get rid of the initial value and watch what happens. So now, notice that in our first run, we start with 5. And notice it skips 0 here. So it just goes 1, 2, 3, 4, 5 instead of starting at 0. So again, let me show you the last one. This is the index of the array. So here it does every index of the array from 0 through 5, all 6 elements. But when we run it this way, whoops, it skips the first element and uses that as the accumulator. Do you follow that?
Yeah, that's ugly. That's not intuitive.
Yeah. Well, it works for numbers, but it doesn't work for a lot of other things. So in the case of if we're trying to do, well, okay, let's just wrap this in a bow. So this is the use case of reduce. You want to aggregate some set of values in a meaningful way where each next value builds upon the previous value. That is the semantic use of reduce. If you use reduce that way, then your code will more or less make sense. So let me adjust the camera here a little bit again. I was playing with this earlier today, and now it's all out of whack. Okay. Now, people use reduce for everything. I've seen people use reduce as a filter function. So they'll do something like this, where their initializer is another array, and then they'll check to see if something matches here, then array.push return array, or they'll use the weird array expansion syntax and things like that. Or I've seen people use reduce as a sum, where you need to determine that something is either true or false by iterating over, and then if it's then they'll return. Let's say like this. People do something like this. So I don't know what this operation is, but they'll return truthy or the condition here. Let's say that, for example. And so this actually should better be a sum. This is my advice, is people need to get better at just straight up normal loops, because everything that you can do with one of these other weird functions, if you don't know how to do it with a normal loop, you're probably going to end up abusing it. Okay, so that out of the way. So we've talked about what's the purpose. We've talked about some abuses. Let's move on to talk about abuses that I am sympathetic to. So chaining promises. When you, and this is actually slightly wrong. Let me go ahead and fix this. Okay, so I'm going to fix that. And then I'll go ahead and post this gist in the chat. Let me make it public instead of private. How do I do that? Go here and make public. There we go. Okay, so I'm going to go ahead and give this to y'all. Also, it looks like my volume's coming in a little hot today. So forgive me. I'm going to, no, I'll just leave it. I'm going to leave the volume alone. We're not going to deal with that. But here's the gist that we're working from. So if you want to chain promises, what you need to do, this is something that's often misunderstood, is you need to actually chain the promises before they are promises, or as they're becoming promises. Because if you get an array of promises, the promises are already happening. They're already doing the stuff. So if we had an array of things, this is kind of, I don't know if I wrote this quite right, but let's say that we had an array of functions that each function is going to do a thing and return a promise. Or we had some common function that we wanted to call on an array of things. We might have something like this, where we're going to await the previous promise, because every async function always returns a promise, and a promise is a value. It's an object. And the funny thing about async await is that await is syntax sugar for handling that in a particular way. So you could have a dot then chain of promises, but if you await, it's syntax sugar for the dot then chain. So I will to make this more clear. No, I don't want to write it the other way, because I don't feel that the other way is actually any clearer or easy to understand. So I'm gonna skip that. So what we have here is first thing that we want to do in this reduce is await a promise. And since it's an async function, it's already returning a promise. We don't have to return anything. It's going to return a promise by default. So we await the previous promise, which basically means that we're building a chain of promises. And then we await this function for whatever it's going to do. Now, this function is not going to get called until the previous promise is awaited. So what actually happens is the reduce runs from beginning to end in its entirety. I need to do one more thing here, actually. So we should have in front of this, we should have an await here as well. The reduce is going to run in its entirety from start to finish, it's going to build up the entire promise chain. So if you were to do a console.log, in fact, we could do this. If you were to do a console.log right here before we await the promise, what you would see is 10 console.logs in a row, I think. Or maybe you wouldn't because of the way that the async encapsulated it. But the point is that however many items are in the array, this is run, but because we're using await, it creates a chain, and so it feels as though they're running one at a time, but the functions themselves are running one at a time, but the aggregation happens ahead of time. Does that make sense? It's really difficult for me to put this into the right words.
Yeah. Is there like an example you could use to make it a little more tangible?
Let me see. Kirglow asks, could this be replaced with promise.all? No, because promise.all runs everything all at once. Everything runs in parallel. This will run one thing at a time. It'll build up the chain all at once, but only one item in the chain will run at a time. So, I would have had to spend more time to come up with a really good example that's not contrived for this. But you can imagine this function is just basically a sleep or a set timeout or a web request or whatever. So what it's going to do is build up a chain of functions that are all ready to go, and then it's going to await them. And because each function is async await chained to the next function, this one has to resolve, and then this one will resolve, and then this one will resolve, and then this one will resolve. So this is an abuse of reduce, because it is, in a way, it's aggregating, but in a way, it's kind of weird. This is not your typical use case for reduce. It's more just that it's a side effect, and this is more or less an idiomatic way to accomplish this. In terms of working with promises, reduce is not intended for this use case, and it's not intuitive, but it happens to work, and it's fairly idiomatic. It kind of makes sense for what JavaScript is and how JavaScript works. So the reason that you have a promise.resolve here, this was part of the question that was brought up in the chat earlier. The reason you've got the promise.resolve here is because if you do not put the promise.resolve, then what will end up happening is that function will become the initializer, the very first function in the array. So if we had 1, 2, 3, 4, 5 functions, and we don't put a promise.resolve, then we would only go through 4 loops. And the first function would be called promise. Here, if this is our accumulator, is the promise chain. And so we would do await function, but we wouldn't be invoking the function. We would just be awaiting a plain value. And if you await, so for example, let's say let n equals await 10, then n will equal to 10. So if you don't do anything but say await 10, then you just return 10. And so that's the potential danger here, is that if you forget to put the promise.resolve, then the bug that works well for numbers won't work well for promises, and you'll find that 4 out of your 5 functions are run, rather than 5 out of your 5 functions are run. Does that make sense?
Yep.
Okay. And the reason go ahead.
To make it a little more tangible for me, if we just made it a set timeout of 1,000, and we had 10 of them, it's going to chain them one by one, and so to be wait 1 second, then another second, then another second, and for a total of 10 seconds. Is that how that chaining works?
Yep.
Okay.
So and let's do this real quick. We're going to do a promise.all versus a reduce. If I could get this to show back up here. All right. So here's our sleep, and we're going to have an async function sleep, and we're just going to await new promise function resolve, and then we're going to put in here set timeout. And I always forget, is it the function first and then the amount of time? I think that's how it goes, but I always forget that one. So here we go. Notice we don't have to return anything. My philosophy is return something or return nothing. Or rather, return something or don't return anything. And because this is async await, we're not actually trying to return any value here. We just want it to wait. So I don't put a return in that it is a promise. So it returns a promise just because of the way it is. All right. So here's our sleep. And we're going to have an array. Actually, let's have an array like this. We'll do 1,000, 30, 500, 3,000. Okay, so that's our array. And we're going to have in here, we're going to have the promise.resolve. We'll await the promise. And then we're going to await sleep in. And then we're going to console.log done, and let's tell it which one it was, I. Okay, so we're going to console.log done, I. And what we are going to see is that each of these is going to happen in order. So we're going to see 0, 1, 2, 3. Okay, 0, 1, 2, 3. Now, if we did promise.all, we're going to have quite a different experience. So let's say that we did a map on this and we did await promise.all of our map. Let's see that should be right there. Boom. They all complete simultaneously. So let me try that again, because we should actually see, the dones come out of order. Let me make sure I got this right. Oh, I see why that didn't work out the way that I thought it would. Now we got to get rid of this await promise. Okay, so we should actually see these come out of order. Why did that not work? Sleep in. Oh, because I still had that hard-coded up there. So let's try this one more time. So there we go. Sleep in. Come on. I still have my console.log. So we should see await sleep in. Did I do this right? Because that was too fast. They shouldn't have all logged out right then. Did I do this entirely wrong the whole way through? No. Okay. So I'm not going to debug this live any more than I already have. We can take a look at this in detail later. But the point is that when there's a promise.all, everything's going to go all at once. And this can cause disk thrashing if you're doing file system reads, or network thrashing. In fact, the network will typically cut you off after about 4 requests at a time. And so it'll keep a pool of requests going, but it'll limit it to somewhere between 4 and 10. If it didn't do that, you could actually start to get blocked by firewalls, because it'd look like an attack if you had 100 items that you needed to batch and then all of them fired off at once. So there's that bit there. Let me go ahead and I'm going to just comment these 2 pieces here. I'm going to check the comments in the chat real quick. And then we're going to move on to the last case. Let's see. Okay, this one was the reduce. So I'm going to put this in here too. Whoops. And then fix this. So sleep in, resolve in, sleep in, resolve in. Oh, did I just copy that wrong? Is that why this didn't work? Okay, I'm going to run this one more time. Oh, there we go. That's it. See? Done. One. That's exactly what I was trying to show. So I was just heat of the moment, live coding. Had some variable wasn't defined. But those are the two differences there. And then the last thing that is an abuse of reduce, but that I'm kind of sort of okay with. First, let me check on the comments here. Yeah, so if you did, first of all, please don't use const for variables. It just, no. Yeah, you can do for let function of array await function. It just feels weird to me because people don't understand how async works. And when you're doing an async loop like that, I think it just makes it even more difficult to understand because people try to use await as if it's synchronous code. But if you don't understand promises, and this is my rule, if you don't understand promises, do not use async await. You need to have a complete and firm understanding of promises because async await builds on promises. It doesn't abstract them away. It doesn't make them disappear. It doesn't make them stop doing what they do. It gives you a syntax sugar that allows you to do some things that are simpler. So for example, you can do await.catch. So you could say await do stuff.catch and then be able to handle errors very well this way. And it's very idiomatic and it can be very nice. And I'll give you a really good example here real quick. So let's say the fs module in Node, if you, let's just do let fs equals require fs.promises, then you can do fs.access path to thing dot catch object, and then you have let error equals await, and then if error, then handle error. Well, basically, typically what you want to do is if there was an error, then you might want to say mkdir or create the file, and if there is not an error, then maybe you want to then read the file or something like that. But that's a case where you can get a really nice clean line of code by using await catch. But if you try to pretend that await is synchronous and you do nest all these try catches in as if it's synchronous code, then you just end up with the try catch pyramid of doom replacing the promise pyramid of doom or the callback pyramid of doom. So you're just trading pyramids of doom. Okay, let me get to the other questions here. Surely I don't know what a quokka. Something quokka would be easier to test this out. I don't know what that means. Are you aware of JS notebooks? Could be a nice way to mark up this learning session. I'm not aware of it. Sleep needs to take the... Oh, thank you, Kirglo. Yes, you saw exactly what was wrong. Yeah, you caught it. Okay, and then the last thing that reduce is used for that I think is not a crime against humanity necessarily is .map allows us to turn an object into an array, right? So let's say we have, we could do object.keys of basically, let's say a hash map. So I'm going to do this here. Oops. So we can do object.keys.hashmap.map, and then we're going to have our keys. And so we could basically say let object equals hashmap key, or let's say let val. And then maybe we would do val.key or .name or something like that is equal to k, and then return val. And so with this, we can use .map to turn an object into an array, which is kind of nice. Sometimes you want to go back and forth between the dictionary or hash map style and the array style. And reduce allows us to do this somewhat the opposite. So now we could have an array.reduce object and element, and we could start with an empty object, and then we could say L, what is it? Object L.name equals L. Return object. So it's an abuse of reduce, but it's one that feels okay. Again, I would suggest that rather than trying to figure out how to abuse things, that instead you just do what's super intuitive and easy to understand, which would be to do a for each and just loop over and do this. And it actually ends up being fewer lines of code. I think this is easier to reason about and fewer lines of code. Okay, so do we have more questions? On the topic of normal loops versus the functional array methods, often you can write code that is more performant with a loop. How much faster the loop would need to be for you to choose it over something written by map-reduce filter? Often people say prioritize readability as JS is a high-level language. Just curious on your thoughts. Yes. So I would say this. I would say 99 times out of 100, you should just be using for each. The cases where you need to use a for, and there's, this is so weird in the JavaScript community because there's all the functional zealots where function is a religion and the god is mathematical purism, that you worship at the altar of the infinite number of combinatorial array methods, right? And yet then so many of JavaScript's just so hodgepodge. So you'll see all these examples where people are using for things that map, sum, filter, and for each work really well for. Those are the ones that I'd say that I use on a daily basis, or yeah, map, sum, for each, and filter. And those are good. And I think most of the time you should be using for each because there are bugs in the language with for. And there's just a lot of really confusing semantics with for that are a lot simpler in my mind when you're using the functional style. For example, with promises, if you try to use the style that looks asynchronous, you're going to do weird things and the code doesn't actually behave the way that it feels like it should. Whereas if you're looking at it in terms of just mapping an array of promised values, to me that feels more idiomatic. But yeah, so I'm just a big fan of for each. I think it's what you should be reaching for most of the time when you want to use for. If you need to interleave channels, so say for example, you are doing some video processing. So you have a video channel, you have a left audio channel and a right audio channel. And if it was 3D video, which no one does anymore because that was cool for all of 10 minutes back in the 2010s or whatever it was. But then you'd have a right and left video channel as well as a right and left audio channel. Or if you're doing surround sound, then you actually have 6 channels. And the way that these audio files are composed is that you interleave the channels. So the first byte is for the leftmost channel, or I don't know exactly how which channels go to which, but basically it's, say, left back, left front, right back, right front, woofer. Center and woofer, right? And so you'd have those channels and every byte is in that sequence. So you actually need to iterate over 6 things at a time. And I would say it's quite common to have a situation where you need to iterate over 2 things at a time because you're dealing with something that is interleaved. Yes, for can be more performant. If you're in that situation, JavaScript's probably not the right tool for the job. You should probably be using, say, Rust. But if you have measured the performance and you can tell that for is actually more performant, because a lot of times what will happen is the just-in-time compiler changes its behavior in different contexts. So if you are doing, say, a benchmark test, it might be somewhat faster, but in the real world scenario, it may not be faster. And again, usually it doesn't matter. I have run into a case where I personally had to switch to for. What I was doing was iterating over literally millions of bytes for an image. I was iterating over some data that came from a sensor system, and I was generating essentially a heat map from the sensor system, and then presenting that as a PNG or I guess, just an image, a canvas image. And so because I was literally going over millions of things per second, there were a couple of weird optimizations that I had to do. One was that I had to use a for loop. Another was that I had to do, I had to switch all of the multiplication to addition, because if you do addition multiple times, it's faster than doing multiplication once. So if you needed to multiply by 5, it's quicker to just add 5 times, which is, weird, but and it depends on the implementation, because the JIT optimizer will do different things and between different versions of V8. So every time a new version of Node comes out, the JIT optimization may be different. So you should not go in blindly thinking that 4 is going to be faster every time, because sometimes it will be and sometimes it may not be. Okay. Let's see. Do I have a strong opinion for versus while true? Oh, and to the other point, I was going to say, always prioritize readability. So for example, look at the difference between these two. This is not, it's an abuse of reduce that I can live with, but look at how much more readable this is. Choose readability, definitely. But for versus while, I'm going to say always just learn how to use for loops. Don't forget about do while and reduce and all that stuff. Just get familiar with for and for each. So yeah, I would say this is actually what I prefer. And I know that this is a little bit weird, and almost no one is going to say to do this. In fact, you could certainly argue with what I just said that while true is more readable than that. But my point is that you should learn as few things as possible and be as good as you can be with as few things that you can learn. And because people fundamentally don't know how to do just basic loops, I don't want anybody to if you know how to do what you need to do with a for loop, A, you don't need any of the other loops, and B, if you did need the other loops, you can, or if you wanted to use the other loops because of the syntax sugar of it, you would know which loop to use. Because when do X, Y, there's all this, there's just too many, I guess, while, this is a while do, basically. Yeah. And I think do while loops are a thing in JavaScript. I actually don't remember, but I'm pretty sure they are. But I would say just learn how to do everything you need to do with for. And if you know how to do everything you need to do with for, then if the situation comes up where it feels more appropriate to use while or do while, or some languages have an actual loop that's just called loop, that is the same thing as while true, and so on and so forth, you'll know what to do. But focus on for. Yeah, that's what I'm going to say about that. Okay. All right, so this maybe went a little bit longer than what I was hoping for. I in my mind, I named this series that I haven't done yet, Bytes of Wisdom, which is going to be little 5-minute bites. And this has been 45 minutes, so not quite a bite of wisdom, but
It's a buffet of wisdom.
I don't know if it's quite a buffet either. It's not quite meaty enough, but we'll see. All right, let me see if there's any more comments. Great point about the JIT compiler. Thanks for the in-depth answer. You are welcome, DW. Again, thumbs up, sub and follow if you got them and want them. Otherwise, thumbs down if you thought this was a bunch of crap. It's okay to let me know that too. And I'll wait around for another 30 seconds for any other questions, and then I'm going to switch over to doing a live coding work stream because I got some work to do. What I'm going to be working on there is I'm rewriting some code with regex to restructure all of the imports so that circular dependency problems are resolved. This is something I actually had about a week ago that I was working on. Okay. Kai, any questions or comments from you? Kirglo, DW, anything else? The other people that are on the stream? Jay?
No, I just I have been using while loops, like doing tree traversals and stuff like that, like for a breadth first search. If I have a queue that changes in size, but other than that, I don't really use them. I like the for loop philosophy.
Yeah, and Go only has the for loop. It does not have any other type of loop, and I think that that's a very smart choice. I'm very sad that generics have officially landed in Go, because that means that libraries like Lodash can now be developed in Go. So whereas before, all Go code by necessity had to be very clean, we're going to start to see lots of abuses of things like reduce and Go as those utility libraries start to abound, because when people have a tool, they believe that for some reason they need the tool, even though they clearly never needed it before. All right. Well, with that, thanks for joining in, all of you. Jay and let's see, it was Josue and Jay, and who else was Duncan. Thanks to all of you for having the discussion in the Discord. I will drop a link to the Discord for anybody that wants to join in there. So, oh, whoops. Okay, click. There we go. And there's a live streams channel if you want to get notified when the live streams are happening. Here's the link to the Discord. There you go. And with that, I'm going to call it. So again, thank you. Like, sub, follow, all the things. Remember, my birthday's coming up. 5 months. Let's get to the 5K and the 10 average viewers. We can do it as a team. It feels so weird when YouTubers say stuff like that. It's like, you can't see me. But in your case, Jay, I actually do have Jay on the screen here.
Yep.
Say hello, everybody.
Hello.
All right. So we're out. Adios.